Programming languages come and go. Some stick around because they are good at what they do. Others disappear faster than your New Year's resolutions. And then there's Fortran, a language that's been around since the 1950s and somehow still hasn't died. Welcome back to PandaProgramming. This is the format where we dive into ancient programming languages, so stay tuned and enjoy. Before we had Python bros arguing about tabs versus spaces, there was a small team at IBM dealing with a much worse problem. Programming in the early 1950s meant writing rows and rows of zeros and ones by hand. John Backus, the guy who would eventually create Fortran, called it hand-to-hand combat with the machine. And the machine usually won. In late 1953, Backus walked up to his managers at IBM with a proposal. He wanted to build a programming language that didn't require you to have a PhD in pain tolerance. The idea was simple: turn math equations into code that computers could actually understand. His bosses gave him a budget and told him to hire a team. The recruitment ads were something else. They said people who enjoyed chess or solving puzzles would find the work absorbing. What they got was one of the weirdest teams in computing history. A chess wizard, a cryptographer, a crystallographer, a researcher from MIT, and Lois Hyped, fresh out of Vassar's math program. She was the only woman on the team and later said nobody was worried about seeming stupid. They were all just learning together. The team worked crazy hours, mostly at night because that's when they could get time on the IBM 704 to test their code. Long winter days were broken up by snowball fights outside the office. What was supposed to take 6 months ended up taking 3 years. In 1957, they shipped the IBM Mathematical Formula Translating System, or as everyone started calling it, Fortran. And if you want to keep hearing stories about tech that actually mattered, instead of just hyped up garbage, hit that subscribe button. You see, Fortran wasn't just another programming language. It was the first high-level language that actually worked. Before Fortran, if you wanted a computer to do something, you had to translate your problem into machine code yourself. Fortran did that translation for you. And here's the kicker, it did it fast. The code Fortran produced ran almost as fast as anything a human could write by hand. This was huge for scientists and engineers. They could finally write programs that looked like actual math instead of cryptic number sequences. Need to calculate missile trajectories? Write it in Fortran. Need to model combustion in a rocket engine? Fortran. Need to figure out if your spacecraft will melt on re-entry? You guessed it, Fortran. By the time NASA was gearing up for the Apollo program in the 1960s, Fortran had become the standard. Engineers at places like North American Aviation, in Downey and Rocketdyne were using it for everything. Testing rocket engines, analyzing combustion performance, spacecraft thermal analysis, you name it. The Apollo missions themselves were a Fortran operation behind the scenes. Not the onboard computers. Those used a special assembly language and had their code literally hand-woven into rope memory. But all the simulations and testing that happened before launch, that was Fortran territory. Former Apollo engineers have talked about using Fortran to analyze test firing data and model rocket processes. One engineer mentioned they used Fortran 4 during the Apollo program and had to make some software changes when newer versions came out. Another engineer who worked at the MIT Instrumentation Lab said the missions were simulated on a massive IBM 360 Model 75 computer, using a language called MAC that was similar to Fortran. Ground control systems used Fortran too. Programs for mission planning, trajectory calculations, and performance predictions were all written in it. Engineers would write their code on punch cards, the old 80-column kind, and submit them for compilation. You'd wait at least 12 hours to see if your program even worked. After Apollo 1, NASA upgraded to the IBM 360 with what was then considered an insane 1 megabyte of memory. Fast forward to today, and Fortran is somehow still around. NASA still uses it. Climate scientists use it. Weather prediction models use it. The codes that run on supercomputers to model Earth's atmosphere and predict hurricanes? Still Fortran. In 2017, NASA announced a code optimization competition for a Navier-Stokes equation solver used to model aerodynamics. The catch was it had to be in Fortran. People thought nobody would apply because Fortran is perceived as this ancient relic. But here's the thing, for heavy number crunching, Fortran is still incredibly good at what it does. The language has been updated constantly. Fortran 2023 is the current standard as of late 2023. It's got modern features now, object-oriented programming, modules, parallel computing support, but the core strength remains the same. It was designed to turn math into code efficiently, and it still does that better than most alternatives. Climate models are some of the most complex software ever written. Many of them are millions of lines of Fortran code. NOAA and NCAR, NASA's climate modeling centers, they're all running Fortran. These aren't small hobby projects. They're massive simulations that run on supercomputers and produce hundreds of terabytes of data. Most programming languages from the 1950s are dead. COBOL is barely hanging on in legacy banking systems. But Fortran is different. It survived because it was actually good at solving real problems. Scientists and engineers aren't programmers in the traditional sense. They're physicists, mathematicians, climate researchers. They need a tool that gets out of their way and lets them write equations. Fortran does that. It's simple enough that a domain specialist can write bad code and still get good results. The language also benefits from decades of compiler optimization. Fortran compilers are stupidly fast because they've been refined for 70 years. For high-performance computing, where every nanosecond matters, that's not a small thing. There's a reason the LINPACK benchmark, the standard test used to rank the world's fastest supercomputers in the top 500 list, is written in Fortran. It's been measuring supercomputer performance since 1979. Every 6 months, when the new rankings come out, all those petaflop and exaflop numbers everyone obsesses over, those come from running Fortran code. The benchmark solves dense systems of linear equations, and Fortran handles that workload better than anything else. When you're trying to prove your supercomputer is the fastest in the world, you don't reach for Python. And there's the legacy code problem. NASA and other organizations have millions of lines of Fortran code that works. Rewriting that in Python or C++ would cost billions and introduce new bugs, so they keep using Fortran and updating it as needed. There's this weird narrative that Fortran is outdated. MIT made headlines a few years ago saying their students couldn't even read the Fortran in old climate models. They decided to rewrite everything in Julia. That's one approach. But calling Fortran outdated is kind of missing the point. It's not outdated if it's still doing its job better than the alternatives. The latest standard came out in 2018. Active development, active community, still used for the world's most demanding scientific calculations. The people who think Fortran is dead are usually the ones who've never had to optimize code for a supercomputer or model fluid dynamics at scale. In those domains, Fortran isn't a curiosity, it's the standard. Fortran's story is basically the opposite of the hype cycle we're used to in tech. No massive marketing campaign, no venture capital, no promises to revolutionize everything. Just a tool that solved a specific problem really well and kept getting better at it. While JavaScript frameworks get released every 60 seconds and burn out in 2 years, Fortran just kept existing, quietly powering rocket launches, climate predictions, and scientific breakthroughs. Not because it's trendy, but because it works. The engineers who built the Apollo program didn't care about using the coolest new language. They cared about getting to the moon and coming back alive. Fortran helped them do that. And 70 years later, it's still helping us understand our climate, design better aircraft, and push the boundaries of what computers can calculate. So next time someone tells you a technology is outdated, ask them if it still does its job, because Fortran sure does. and it's not going anywhere. Now if you really enjoyed watching this video, then like it and consider subscribing to the channel, as we will be bringing up more anticipated and exciting content soon. Thank you for your time.